All right, so I'm going to be talking about a package that we made, actually a couple packages we made for using BERT in R. BERT, I'm going to explain what that is, but that's the Google Natural Language Processing Framework, and it's really cool. All right. First I want to acknowledge, Jonathan Bratt, who did really most of the work on the packages. He couldn't be here today, unfortunately, but his GitHub will be featured very prominently throughout this. He's a colleague of mine at Macmillan Learning, where we are both data scientists. All right, and so if you want to follow along, you can go to this randomly generated URL that Bitly put together. That will take you to a tweet, which you can like and retweet and reply to. And then you can click through to go to my slide deck. So yeah, I'm going to today be doing a really brief overview of transfer learning because that's what BERT brings to natural language processing. Then I'm going to talk a little bit about BERT. I'm going to talk about the two packages that we made to use BERT in R. And then we're going to see how you can kind of see how BERT thinks, sort of. Looking at attention and at the layer outputs. And all of this hopefully will make more sense by the end of the talk. All right, so first, transfer learning. A key example of this was about 5 years ago. People were making models to classify the ImageNet image set. It's like 14, 15 million images tagged to like 20,000 categories. And it got to a point, or it is very much to a point, where we can see that on the early layers of these neural nets, you get just simple feature extractors. So here we can see that it's an edge detector. It can see light to dark or dark to light edges. And then things like that add up together where you start getting things like a face detector or a text detector in later layers. I've got a link to this in the slide deck if you go to the GitHub, and the video that they made about this is just amazing. It's really mind-blowing how they were able to really kind of explain how this neural net is doing image classification. And an important thing here is no one trained it to detect faces or to detect text. For example, one of the categories was bookcases. And so in order to find bookcases, it figured out, so to speak, that it needs to be able to find text to find a book, to find a bookcase. And so it just learned these deeper layers. We've had kind of transfer learning in natural language processing for a while now in the form of word embeddings. Word2Vec and glove are two examples of that. And the famous case that really people should find other ones because if only this works, that's not that impressive. But if you take the vector for king, you subtract the vector for man, you add the vector for woman, the closest word is queen, which is pretty cool. You can start doing math with language. The problem with that is each word has one embedding. So if you have these two sentences, I saw the branch on the bank versus I saw the branch of the bank, those two sentences, like every word in those is going to have almost exactly the same, well, every word except on and of will have exactly the same embedding. But branch in the first sentence means a stick, and bank on the first sentence means the edge of a river, whereas branch in the second sentence is a subset of a bank, which is a building. So last year there were a whole bunch of advancements in NLP doing more kind of sentence level embedding, and it culminated in October of last year with BERT. That stands for Bidirectional Encoder Representations from Transformers. We're going to look at what transformers are a little bit, and hopefully it'll kind of make sense. The bidirectional part is just they're looking at both ends of the sentence. They'll mask a word in the middle and then use the words before it and after it to figure out what that word was. which obviously that's how language actually works, is the whole sentence matters. So that was a good advancement. This was trained with a very large corpus. They used Wikipedia and Google Books, like all of the books that they've scanned. And the cool thing about this is it is transferable. You can put in a sentence and extract some features and use them for your own model. You just take off their classification task at the end, put on your own, and you can do some cool things. And to do that in R, we have this package, RBERT. It's available on GitHub. You can use DevTools to install it right now. It's an implementation of BERT in R. Right now, you can use it for that feature extraction, where you just pull out, you give it a sentence, or tons of sentences, and for each sentence, it gives you a vector to represent that sentence. So you can do that right now. We're working right now on making it work for fine-tuning, where you could put your own neural net piece on the end of it and let it kind of relax and find new features. That'll probably be a future talk in January. All right, and then we also made this RBERT Vis. This has basically two functions, visualize attention and display PCA. We're going to be looking at that because those two functions, the reason we made this package is it lets you see how BERT is thinking, which, again, will make more sense in a second. So, all right, attention. The code on the left here shows just, it's a little aspirational. It'll work this way next week. If you want to use it today, go look at the code for my slides, and you can see the extra arguments that are in there. But this is how it'll work next week. But it's almost this simple. It's just simpler, or it's a little bit more complicated inside. But you tell it what model you're going to use. You give it a sentence. Tell it what layers you care about. In the BERT base, there are 12 layers. And you tell it you want attention. And it will pull out the attention, send that through RBERT Vis, and it creates this HTML widget, which I am going to hopefully, yes. All right. So what we're looking at here is, again, this particular pre-trained BERT model has 12 layers, so we can go through and look at different layers. This drop-down isn't important for most tasks, but that's if you feed it 2 sentences at a time, it can compare across the sentences, but we're just going to look at one sentence versus itself. And then within each layer, what the transformer is it has these heads. We're going to just focus on one head right now. In this particular head, it does some math, and it decides what other words in the sentence should each token pay attention to. The CLS token is just it's class is what it stands for, and it's just like an overall token for the whole sentence. But each word in the sentence is given like a weight of how much it should pay attention to each other word, and then it uses that weight to update its own vector. And as you go through the layers, the vectors change. We're going to see how that comes out. Oh, an important thing here is, surprisingly, the vocabulary BERT uses isn't that good because it can't be a good vocabulary if it doesn't know the word taco. So it breaks it down into ta and kos. But as it goes through the layers, it's able to figure out that those go together and that they mean something important clearly. All right, so something interesting, we'll look at it here and then we're going to look at it for the other sentence, is just a few layers in, you get something that's kind of like the edge detectors, where it doesn't look like much here, but it's just, hey, pay attention to the next word. The next word might matter. Use the weight from that. And so each of these words, or other than the weird tokens at the beginning and end, they're just looking at the next token. And let's go back. All right. So if we look at some more complicated sentences, we've got the chicken didn't cross the road because it was too tired. The chicken didn't cross the road because it was too wide. The dog fetched the ball. It was excited. When the dog fetched the ball, it was blue. Obviously, the last word in each of those sentences changes what it means within that sentence. As a human, we can read this and say, oh yeah, it's the chicken, it's the road, it's the dog, it's the ball. And the cool thing is, well, I'm sorry, I'm not getting into the cool thing yet. So, across all those sentences, that layer 3, head 1 is doing the same thing. It's saying, hey, look at the next word. Most of the point of this is just to see that a head has a function. A head is doing something. If we look at layer 9, head 5, it's a pronoun resolution head. And this is kind of equivalent to that face detector. No one told this thing to learn to find pronouns. Just in order to understand language, that was something that had to train. And so we've got it chicken. And if we look, it's it road, it dog, and it ball. Now, it's a little, some of them are a little distributed. It's not 100% sure. But that's really cool. It really is kind of understanding the language. So the other thing, all those heads add up on each of those layers to give us an output for that layer. To demonstrate this, I did a poll online where I just asked people to submit sentences. One sentence about learning using the word train, as in teach, and then another sentence about travel using the word train, as in the vehicle. I've got some code there. Again, so it's just, we can extract the features. We're saying we want the output. Here we're going to start at layer 0, which is just the input embeddings that it gives before it does any travel through the neural network. And then I tie those labels back onto, or the labels back to that output. And so this is just looking at one example of each of the words that people used. So they used train down here, trains, trained, and training. And at layer 0, that's all it knows. Is it just has one thing for each word, one point. When we add all the other ones, there's a little bit of wiggle on them because it also takes the position within the sentence into context. But for the most part, these are all train, these are all trains, these are all trained, and these are all training. And here the green means that it's teach, and the black means that it's a locomotive. And so as we step through the layers, we can see that it actually does start to separate those by meaning. Except for this one. Wait, what's going on with that one? And when I first made this, I was like, oh crap, I'm going to have to find something else to use for my demo because I want to show it actually working. But then I went and looked up the sentence, and again, this was gathered from random people on the internet. So that wasn't a sentence about a locomotive. It's not really even a sentence, but it was classified into teach because it's more teach than it is vehicle. All right. So we have a lot to do. RBERT is usable now, but it can be a lot better. Like I said, some of this is aspirational already that I wanted to show how easy it's going to be in about a week. It's already pretty easy. I've used it to build a couple of models. It works really insanely well, that just pulling out those features and then using those within XGBoost, and it can do classification really well. Our goal is to have it up on CRAN by the end of this year, which is about a month away, so we're pushing hard on that. And towards that, right now, it works with TensorFlow 1.13 in that range. We're going to upgrade it to TensorFlow 2.0, which just came out. That's in testing right now, and actually Jonathan is back in Austin working on that right now. The other thing we want to do is we basically copied this code from the Google Python code. It's under the hood. It's got a lot of weird things that it's doing. And on the front end, it's not friendly. So we're working on that, making it more friendly. And then if you've worked with tidy models, we're going to put a recipe step in there to make extracting those features super easy. So you can just pull out the features of your sentences and use them within a model. We will have a poster at our Studio Conf in January. And I encourage everyone to go to bit.ly/RBERT poster and give us ideas of what you would like to see on that poster. We might just use the submissions of ideas in our poster because that's text that we could parse. But whatever you might have, we don't know yet. We're not sure what we're going to show. There's lots of cool things that we could do. All right, you can contact me. So you might be shocked to hear that I'm on Twitter a lot. I'm at John the Geek. That's Jon. You can go there, maybe like and reply and retweet some things. You can find our packages on GitHub at Jonathan Bratt's GitHub/RBERT and /RBERT Vis. Again, those are usable right now. And you can just watch them every day. They get a little better. You can find my GitHub. I've got my forks of these, but I've also got some other stuff there. You can also find me on the R4DS online learning community at r4ds.online. Most Saturdays, I host an office hour there for just any random R questions you might have. Not this week, and actually not next week, but most Saturdays. And I also have a podcast, tidytuesday.com. Hopefully, if he's still in the area, I'm going to be interviewing David Robinson, and that'll be up on Tuesday. But normally it's a podcast about visualization, which is hard to do sometimes, but I think I do okay. And I managed to talk very quickly, and so I'm going to give you back a few minutes.